This is OwlUp, where learning happens in minutes, not hours. For a deeper journey, explore all our courses at owlup.co. Now, let's dive in. Welcome to Chapter 1 of The Alchemist's Wisdom, Medieval Alchemy for Modern Transformation. In this episode, titled The Ancient Quest for Gold, The Basics of Alchemy, we're going to explore the fascinating world of medieval alchemy, unpacking its key goals and essential components. So, get ready to uncover the secrets of an ancient craft that still resonates today. Let's dive in. A man boils hundreds of buckets of urine in a dark 17th century cellar, not to make medicine, but to hunt for gold. He fails spectacularly and accidentally discovers phosphorus, the element that makes matches glow. That's the kind of sideways success alchemy is full of. Gold, oddly enough, was only half the story. The other half was meaning. Behind the smoky glassware and strange diagrams, many alchemists thought they were refining themselves as much as their metals. A failed experiment was not just bad technique, it could be a sign that the alchemist's own inner mixture was off, impure motives leading to impure results. Their notebooks read less like lab reports and more like a hybrid of recipe book, prayer journal, and puzzle. Instead of clear labels, they hid processes behind symbols: lions devouring the sun, eagles tearing at toads, a king and queen dissolving in a bath. To them, nature spoke in riddles, and the laboratory was where you tried to answer back. In a way, each furnace was like a small theater where matter, spirit, and metaphor all stepped onto the same crowded stage and tried to improvise a new script. So to understand these early experimenters, we need to step back from the cartoon image of robed charlatans chasing quick riches. Many were skilled artisans and technicians, closer to today's lab chemists and engineers than to stage magicians. They inherited techniques from metalworkers, dyers, and glassmakers, then pushed them further, testing how substances behaved under heat, cold, grinding, and distillation. Their workshops hummed like small startups of the pre-modern world, where failure was constant but recorded, debated, and sometimes secretly sold to princes eager for military alloys, stronger pigments, or tougher glass. To see what these experimenters were actually doing, follow them into the details of their workbench. One of the earliest we can glimpse is Mary the Jewess, active in Roman-era Egypt. Later writers credit her with devising the tribikos, a three-spouted still for repeated distillation, and the balneum Mariae, or Mary's bath, a gentle water bath still used in labs today as the Bain Marie. Her designs show that, from the very start, this tradition was about controlling heat and separation with precision, not just tossing things in a pot and hoping for miracles. Centuries later, in the Islamic world, Jabir ibn Hayyan and his circle pushed this apparatus culture much further. Working under Abbasid patronage, they sorted substances into categories: spirits that fly off in vapor, metals that endure the fire, salts that crystallize. Their descriptions of what we'd now recognize as nitric and hydrochloric acids let artisans dissolve, etch, and refine metals in new ways. Combined, those acids became aqua regia, the only liquid that can eat gold. Ironically, the quest to perfect gold included learning how to destroy it. By the late Middle Ages in Europe, the promise of artificial gold had attracted both serious practitioners and outright frauds. The papal bull Spondent quas non exhibent, they promise what they do not deliver, didn't ban experiments, it targeted swindlers who sold princes fake transmutation schemes. The very need for such a law shows how persuasive the stories had become, and how often investors were burned. Yet even then, not everyone in this world was chasing coins. Some focused on pigments that wouldn't fade in church windows, or on medicines distilled from metals and minerals. When Paracelsus later argued that the true task was to make arcana that heal the body, he was redirecting an older craft rather than inventing a new one. Meanwhile, symbolic language thickened around the furnaces. Sulfur, mercury, and salt became more than substances. They marked active, volatile, and fixed principles that could be read in both metals and human temperaments. Dragons and eagles, kings and queens, encoded multi-step procedures and pictures that also invited moral reflection. The same recipe could be read as a guide to preparing an alloy or as a drama of death, purification, and rebirth. Over time, this double vision, matter and meaning, left two legacies. One fed straight into modern laboratory practice: glassware shapes, distillation chains, careful notes on color changes and odors. The other seeped into philosophy, literature, and eventually psychology, where alchemical came to describe any slow, transformative process of breakdown and recombination. Even after professional chemists stripped away the dragons, the basic question remains stubbornly alive. When you change matter, how much do you also change yourself? A useful way to feel what alchemists were attempting is to zoom in on a single, ordinary material and watch it change. Take common sand. In the furnace, it softens, then slumps, then clears into glass, a substance that is neither quite liquid nor solid in the everyday sense. For an alchemist, that in-between state hinted that matter might be more negotiable than it looks, that substances had hidden paths from one form to another if you could only find the right sequence of treatments. Or consider how dull copper can be persuaded by careful alloying to glow like gold in the right light. No transmutation, just craft and close attention to color and luster. Their manuscripts linger on such shifts the way a painter studies how one pigment behaves next to another. They weren't only cataloging recipes, they were tracing a kind of biography of materials, where they came from, how they grew up in the fire, and which companions in the crucible brought out their strangest possibilities. Today, researchers feed alchemical notebooks into algorithms that trace obscure ingredient lists the way a music app recognizes songs from a few notes. Cryptic diagrams become data, revealing forgotten recipes for pigments, alloys, even lost glass formulas. Meanwhile, physicists chase precise nuclear tweaks to craft rare isotopes for scans and cancer care. Therapists, too, borrow that old furnace language to chart slow personal change, treating the psyche like a workshop where failures become reagents for the next experiment. So the old dream of gold-making survives, just shifted. We now transmute data into insight, trash into materials, setbacks into new designs. Your challenge this week: pick one stubborn problem and treat it like an alchemical puzzle. Change the container, the order, or the heat of effort, and note how the outcome shifts, like clay under a new sculptor's touch. This was OwlUp, your daily step forward. To keep learning with structured courses and more insights, go to owlup.co. Until tomorrow!